Hello everyone, thanks for joining the presentation. I'm Oisha Bintahak and I will present our work PRISM-CAFO, Prior Conditioned Remote Sensing Infrastructure Segmentation and Mapping for CAFOs. In this work, our core research question is, can object-centric representations combined with domain priors yield more accurate and interpretable scene classification than vision-only models? Traditional vision classifiers rely on global visual features, often ignoring object composition and spatial structure. We investigate whether grounding classification in detected infrastructure and structured prior knowledge can lead to a better performance and explanation. Here, we study rural US agricultural landscapes using night aerial imagery. We focus on concentrated animal feeding operation, in short CAFOs, infrastructure detection and categorization. CAFO analysis is challenging because its infrastructure layouts vary widely. Also, CAFO structures can resemble non-CAFO facilities. CAFO component level data such as burn manure pond are not available at all. Here, our goal is to classify CAFO type accurately, which is also infrastructure aware and interpretable. Why monitoring CAFO is important? Monitoring CAFOs is important due to environmental, public health, and policy implications. These facilities influence greenhouse emissions, water quality, and also land use. However, manual surveys are expensive and incomplete. Automated remote sensing offers scalable monitoring, characterization, and also tracking. Now I will introduce our pipeline. Our pipeline begins by extracting deep visual features. The input image passes through an encoder, producing spatial embeddings that capture textures, patterns, and contextual cues. In parallel, we perform infrastructure detection. We fine-tune YOLO V8 on our carefully curated CAFO dataset, enabling it to reliably propose bounding boxes for domain-specific structures such as burns and manure ponds. Next, we use SAM2 to generate high-quality segmentation masks. While SAM2 produces many candidate masks, these are class-agnostic and include irrelevant regions. To obtain precise infrastructure masks, we combine YOLO V8 detection, SAM2 masks, and rule-based filtering. This fusion step yields well-verified, semantically consistent infrastructure masks. We then use these masks and with visual embedding and pass it to the mask-guided spatial attention module. This module allows the classifier to focus on meaningful infrastructure regions rather than background clutter. Instead of global pooling, we aggregate features only over masked infrastructure region. This masked attention pooling produces layout-sensitive and object-aware embedding. Next, we integrate our domain knowledge prior, such as area ratios, infrastructure proximity relationships, and so on. Visual features and priors are fused before the final classification. This enables infrastructure and relation-aware classification categorization. Our framework provides object-level interpretability. Compared to vision-only GradCAM maps, PRISM-CAFO highlights meaningful infrastructure like burns, manure ponds, and so on. Prediction becomes spatially grounded and easier to trust. Across multiple backgrounds, our method consistently improves performance. We observe up to a 15% F1 improvement, especially under spatial splits. We also do a lot of component level analysis. We saw that gradient activation analysis shows that burn area is the most influential visual features, also show that domain priors and burn pond proximity adds discriminative signals. Mask level analysis reveals burn masks have the highest impact for swine classification, whereas manure lagoons are critical for swine and beef both. Multi-component diversity improves dairy recognition. To summarize, we introduce detector-anchored infrastructure extraction, where we propose mask-guided spatial attention, prior conditioned feature fusion, and all of this module always shows consistent performance gains. Also, we have object-level interpretability. Thank you for your attention. You can find the paper at the provided link, and I would be happy to answer any questions. Please feel free to reach out.